Hey everyone, welcome to Data Umbrella's webinar. I'm going to do a brief introduction and we'll open up the presentation to Sam, our speaker. And if you have any questions, ask them in the chat and we'll get them answered at the end of the webinar. This is being recorded and will be placed on our YouTube, usually within 24 hours. What is Data Umbrella? We're a community for underrepresented persons in data science, and we are a nonprofit organization. My name is Reshma Sheikh. I'm based in New York City, and there's a whole team that makes these webinars happen. There's Beryl out of Kenya, Christina is in New York as well, and Sangam is out of India. And we have a new volunteer on our team recently who's joining us. It's Mo from Vermont. We have a code of conduct, and we thank you for helping to make this some welcoming, friendly community that people want to keep returning to. Various ways to support Data Umbrella. The first is the code of conduct, and we'd love it if you would share our events with people in your network. We also have some projects on GitHub that are open source, such as timestamps for our videos, our website. You know, if you know CSS, HTML, we have some issues open. We also have our blog is on our website, and a data events board, which is currently offline, but we hope to get it online soon. If you'd like to make a donation to Data Umbrella, we are on every.org as with Data Umbrella. If you want to subscribe to a YouTube channel, we have a really rich library of resources that are related to Python, data science, open source, RStats, career development. So we encourage you to check it out. Some of our playlists include career advice, data visualization, data science for beginners, contributing to open source with some focus on scikit-learn, PyMC, and NumPy. We also have a monthly newsletter, and I'll share a link to that in the chat, and it goes out usually the first of the month, dataumbrella.substack.com, and we promise not to spam you. These are our most common social media links. This webinar platform is Big Marker, and we have a live transcript. So if you would like a live transcript, at the very top, there are two letters CC for closed captioning. So feel free to click on that. And it is available in different languages as well, although I'm not sure how accurate it is relative to the English transcript. We also have an online suggestion box, and I'll share the link to that if you have any suggestions for future event topics, if you'd like feedback, if you'd like to send us feedback on this event, if you want to share any technical issues you've encountered, if you'd like to do a talk for Data Umbrella, let us know. Our next event is on January 7th, which is Make Your Own Jupyter Lab Extension. Today's talk is Intro to Git with Sam Miyamoto. Sam is a software engineer and civic tech enthusiast based in Los Angeles, California, with experience in varying roles in sectors like clean transportation, renewable energy, data storage, public health, and more. She's dedicated to developing solutions that have impact. Fun fact, she once went composting with a group of friends in Griffith Park. And one other fun fact is that I met Sam through Spec Collective, and she was one of the engineers who worked on our events board, which is right now offline because we are waiting to renew our DigitalOcean credits. And so once that gets back online, you'll be able to see that events board. And with that, I am going to hand open the screen share and the microphone to Sam.
Thanks so much, Reshma. Hi, everyone. Thanks for being here. Let me pull up my slides really quick. Oh, no, sorry. Okay. So to get started, hello, everyone. Welcome to my introduction to Git Talk. Thank you, Reshma, for that wonderful introduction. Yes, I am a software engineer in the LA area, and I came to Data Umbrella by way of Hackbright and Spec. And I've been part of the Data Umbrella community for some time. So today we are going to dive into Git, which is one of the most widely used version control systems available. So whether you're a beginner or looking to solidify some Git skills, this session is going to cover some key concepts and commands and workflows that can help you get started with Git. So to get the most out of this presentation, I do encourage you to follow along, but because these are recorded, if you'd like to get a glimpse and come back when the recording's up, that works well. I do like that format. There's a bit of material, so please feel free to pause me along for questions anytime. And there's also some time at the end for questions, which might be a touch better. So move on to the agenda. So we got introduction, overview, some vocab and terminology, covering Git branching, a demo, demos of VS Code, collaborating in the cloud, some topics for continued learning, and then questions and answers and some wrap. So I've covered this already, so I'll move forward to the next slide. What exactly is Git? I'll give here a 30,000-foot view and maybe some details. So Git is an open source distributed version control system / source code management SCM tool, which means that it helps developers track and manage changes in their code base. It allows software developers and data scientists to collaborate on development of solutions. And it means that they can also, manage and track changes in their code base. So instead of working on a single server, every contributor and developer and data science can have their own local copy of the project on their machine. Git enables collaborative development by allowing team members to work on different features and then to integrate their changes later. So Git is a version control software that was created in 2005 by the folks behind the Linux operating system, especially its creator, Linus Torvalds. Git is written mainly in the C language, and at a recent Stack Overflow developer survey early in 2023, about 93% of developers use Git as a version control system. So why should you use Git? Git is useful because of a few things, such as collaboration, versioning, branching, and its distributed nature. And lastly, Git has integrity because each commit is assigned something called a checksum before it is stored in its own file system. So that means that it's impossible to change the contents of any file or directory without Git knowing about it. This functionality is built into Git and is kind of integral to its own philosophy. I've included the documentation to Git at the end of the presentation, so if you'd like to take a look there, you can. So long story short, you can't lose information as it's being developed or get any kind of file corruption without Git being able to see that on its own side. So that checksum process is not in scope here. So, and lastly, while Git is extremely popular, it's not the only kind of version control software that exists. There are other types of systems like Subversion, Mercurial, and Perforce that are not necessarily distributed version control systems, but because of its popularity, a lot of familiarity between developers and data scientists, and availability of training documentation, using Git for your workflows is a good option. So I'll move over to the next slide. So Git is, there are 3 stages of a file in Git. So the first is perhaps this called untracked or modified, and the next is staged, and the next is committed. So it can help to think of the file as an item before, during, and after a purchase at the grocery store. So for instance, you have an untracked file here. So this example has file 1, file 2, and file 3. On the command line, you can use git add to move your file into a different phase of the Git process into the stage section. And then the staged section can correspond to kind of the checkout process. And then in that checkout process, you log the change by running git commit, and to kind of go out the door and make sure that you have your items or your documents or your files with you, you can commit them by finalizing the change with git push over to GitHub, which I will cover earlier. Thanks very much to Reshma for this workflow and diagram. It's quite useful. So I'll move over to the next slide. So here I've included some vocabulary and terminology that I'll be kind of referring to throughout the course of the presentation. I did cover a little in the last slide, so we'll cover some Git terminology that you might see frequently when using it for version control. So understanding the terms can help make working with Git a little bit easier. So firstly is branching. A branch in Git is essentially a separate line of development. it allows you to work on different features or fixes without affecting the main project itself. You can think of it kind of as a fork of the project where you can make some changes independently. Next, there's commits, which I mentioned. A commit in Git just kind of represents a snapshot of your project at a specific point in time. Each commit contains a message kind of describing what changes were made, and that can make it easy to track your project's history and revert any changes when necessary. Then there's something called push. Push means you're sending your local changes to a remote repository, while pull means that you are fetching the latest changes from that remote repo to your local environment. So those commands can help you sync your work. And then because I'll be covering covering examples on both the command line and on VS Code. CLI stands for command line interface or the terminal, and GUI stands for graphical user interface. So for now, I'm going to branch into the key concept behind Git, which is branching. So in Git, branching allows multiple lines of development to exist simultaneously, which is essential for managing different features or fixes within the project. So one common strategy is to create separate branches that stem off the main production branch, often named main or master. So I've labeled it main here. The production branch is usually considered the stable version of your project, the one that's live and ready for deployment. From here, a common workflow, if you're working with other developers or data scientists, involves creating feature branches to work on new features or bug fixes without affecting the stable code base. So I'll move on to the next slide. So here in purple, we have the main branch. So this next slide covers, for instance, you might have a branch called feature orange that turns everything in your code base orange while keeping the production branch untouched, or give the example. In this diagram, this feature orange branch is branching off main and has one commit, which is kind of represented here by the circle and the node. So next slide. So in this diagram, this represents the next flow in the Git branching process, or in the Git in the feature process. So the work on feature orange is now complete with 2 commits, and it has been merged back into this main branch here. So all the work in this orange branch has now been considered part of the main branch. So I'll move on to the next slide. So this example is kind of a hybrid with the examples previously. So after the work on each branch is complete, you can merge it back into production or just another relevant branch. So again, that ensures stability in production environment and allows for parallel development of new features and fixes. So in this diagram here, I'm just showing an example of parallel work where multiple developers can branch off. So for instance, here, while orange was branching off here at the first commit, this feature teal branch started work a little bit afterwards. So the feature teal branch and feature orange are being developed simultaneously. So let me move on to the next slide. And then here, so while feature teal is still under development in this section here, the feature orange branch is already merged back into main. So that's the diagram we saw a couple of slides earlier. And then, okay, and lastly, this teal branch with 1 commit is merged back into main here. And main, again, contains the work that was created on the feature orange branch. And then, lastly, this branching diagram, it might have been a better representation to have a combination of orange and teal, but hopefully the concept is that main now contains the work from the from the orange and teal branch. And at the end, both of the branches have been merged back. So to make a long story short, Git does allow for multiple versions of code to take place simultaneously in a workflow development. So now I'm going to move on to a demo. While I get things ready, I will talk about some kind of prerequisites. So I've downloaded and installed Git on VS Code on my local machine. You may have used VS Code before. It's a code environment and code editor that has a built-in terminal. So that's what I'll be using. There's a bit of a hybrid approach to the development workflows that I have, so it just kind of depends on your preference. VS Code is a code editor that has a lot of tooling and represents the graphical user interface, like I mentioned previously. There are other code editors out there like Atom, Sublime, Vim, and Emacs if you're brave, and also if you want to try it out. So the examples that I'm provided here are tailored to a Mac OS system, but the commands should also be compatible with Windows. So I'll do some initial configuration, and then I'll show 3 workflows on the command line and the GUI. I'll create a Git repository, I'll make a commit, and then I'll create a branch. And then I'll cover connecting to GitHub and do some troubleshooting as well. Some of my workflows might have some commands like git status. That's just kind of for best practices and for kind of quality control along the way. If you'd like to do a little more research on that, there's a lot of online resources for learning Git. I'm more of a visual learner myself, and Git has a variety of options on YouTube and other places. So this presentation does only scratch the surface. And lastly, there is greater Git functionality on the command line, but there are sometimes moments where using a GUI like VS Code can expedite your workflow, depending on just the operating system or depending on how file systems are named. So for instance, if there's spaces in your file system, it could be really useful to work on the GUI. So it's helpful to have an understanding of both options. So moving on. So I'm going to finagle my screen here and share my screen. So please bear with. One moment. Share. Sorry, turn off my camera and share slides. Oh, sorry about it. One moment. Technical difficulties. We are here. Okay. Can you all see and hear? Can you all see my screen?
Yes, we can see the terminal VSC.
Okay, perfect. Let me go ahead and pull up the presentation. Appreciate everyone's patience. Okay. Okay, so what's important now is that we're going to configure something called our Git identity. So this is important because if you don't configure your Git identity on the first installation, Git will just use information from your local machine. So I've configured this previously, but I will go through this as a workflow process. So one command, and these will be on the slides that we'll share after the presentation. So we'll have that available. So here we go. So we'll configure email, config, global user email. Then we'll do my email. And then we'll try this again. And then these commands are configuring our user emails and our names. So I'll configure my name here. Oh no, troubleshooting. Great. So you can override these settings by for specific projects without the global option. So I'm going to rerun the above command and hit the above arrow and shift and remove the global configuration, and that should configure my name for the specific project that I have. Oh, maybe. Okay, let's try one more time.
Sam, is it possible to zoom in a little bit just to make the text a little bigger?
Totally. Sorry about that. We did zoom in a little. Let me try again. How's this?
That's great. Thank you so much.
Thank you so much. I can't see. I have it all. It's all on my screen, so I appreciate the verbal confirmation.
Yeah,
okay,
you're doing great.
Thank you. All right, let's try one more time. So usually you'd be able to configure. You could usually be able to configure your name here. Live troubleshooting. Okay. Let me double check.
Somebody in the chat said Git init missing, perhaps.
I was going to cover Git init later. I think that's a great transition. So I will do that right now. Okay. So if we move over into creating a new local Git repository, sorry about this. Okay. So I'm going to navigate home. And then I'm just going to create a new local Git repository via the command line. And then this will take us through the workflow that may allow us to do the config. So part of the Git process. Thanks, everyone. So we'll make an example. I'm making a directory. Then I'll navigate to that directory. Oops.
Hey, Sam, can you hide your docking station at the bottom, that dock with the...
Oh, yeah, totally. I thought it was not visible.
It was before, and somehow it came back.
Somehow. Okay, somehow. Oh, my goodness. Just a moment. How's that?
That's good.
Okay, perfect. Thank you. Okay. Okay. Back to regularly scheduled programming. Thank you. So now we're going to create a local Git repository. So yes, Git init, and then that should initialize an empty Git repository within this path. So you'll see that, yeah, in the path that we have here. And then because Git creates hidden files, you can confirm the initiation of your repository using a command called lsla. And that will show you the hidden files here. So we will now move on to creating a local Git repository here within VS Code, not necessarily on the command line. So I'm going to navigate out of this directory here and create a new directory called example GUI. And I'm going to open it up really quick here on the sidebar. And that'll take you here onto this panel. Just to make sure, I'll open up Control-J to open up the terminal. If you navigate to the sidebar on the left, you click the source control icon, and then you can click this initialize repository button, and then you can see how it opens up a way to manage your source control. So again, the way to do that is you can create your directory or your folder any way you'd like, and then this source control icon will take you to where you need to go on Git. And then lastly, I am going to create a repository on GitHub. So let me share my screen again. Okay, so if you navigate on GitHub, it would just require you to have an account. So you're seeing kind of the inner workings of my screen. You go to your profile or go to your repositories here in the top right, navigate here to your repositories. You navigate to new. And then I'm going to create a repo name right now. We'll call it intro to Git Live. And you can populate it with a version. You can set it to private or public or private. It just depends on what your needs are. If you're looking to integrate with other tools, it might be better to have it on public. So I'll do that for now. You can initialize a repository with a README. README is kind of documentation for a project. So I will initiate here. I'll cover Git ignores later, but for now, I will select a template. Python template. A license is not necessary, but depending on your needs for your project, it could be a good option to add a license, just to be clear to the online community what your permissions are and what permissions you grant to others. Because for learning purposes, there's no need for this at this moment, so I'm just going to hit create repository. And now we have a repository on GitHub. So I can cover this later if we'd like. Okay, so now we've covered creating a repository on the command line, on the GUI, and in GitHub. So now we're going to go back to VS Code and navigate making commits. So, okay, so we're still in this example GUI directory. So I'm going to scooch out of this and get back into our command line example, because there might be some separate needs there. So in order to make a commit, you do need to have files with some kind of data populated within the file. So I'll use some example text files. So if you So you should see, if you create a file, you should see it show up here on your Explorer. Interesting. You can do code, live troubleshooting, code dot, and then if this command code dot will take you to your current directory here. So now the file that we created in the previous command is showing up like expected in the Explorer. Okay, so I'm going to make some modifications like I mentioned. So ABC 1, 2, 3. And then if we want to see how these edits look on the command line, we're going to type in git status. So that shows us that we're on the main branch here. You can also confirm here on the lower left side. We don't have any commit yet to this branch as expected. And then we have those untracked files that I mentioned earlier. And then so I'm going to go through the workflow of adding this file specifically. So if you do git add example file cli.txt, and then there you won't get any confirmation on the command line, but if you run git status, it will now change from untracked, and then it doesn't reflect modified, but the color coding here is nice from red to green.
Sam, can you zoom in again? The font got really.
Oh no! Oh my gosh! I'm so sorry.
That's good.
There?
Yeah.
Okay. Okay. So before, so untracked files are staged in red. Sorry. And then once you add it with this git add command, you can see that the new file here is staged in green. And if you need to make some changes, Git has nice workflows that kind of just prompt you or give some hints in order to move forward. So now we want to make a commit. We want to confirm that we've made these changes. So I'm going to run git commit and then this M option for message, and then it's my first commit message. Oops. And then it does need to have quotes. So now I'm going to hit enter. And then you'll see that Git outputs some feedback with what you have committed here. Okay. So this is using solely the command line. So if we want to make a commit here in VS Code, I'm going to go back to the other directory. So that's going to take us into the previous directory and navigate us into GUI here. So I'm going to go back. Oh, actually, I should just have these open. Okay. Okay. So now we are going to make a commit here on VS Code. So the way to do that, I'm going to create a new file. So same process as last time. And yeah, finally, it shows up here. So I'm going to make some changes. XYZ 789. And then, so I hit Control S to save. The dot went away. So now see how there's a little notification here on the left that pops up on source control. So if you click on source control, and click on source control, and you can navigate down to this plus button here. You can stage your changes that way. If you hover over, it'll give some IntelliSense as well. And then U stands for untracked. So once we hit the plus sign here, it will stage our changes. And then you can, I think you can see, oh, interesting. No, it'll show up here on stage changes. So we're not done yet. We still need to actually make the commit itself. So if we type up here, you can type your commit message up here. So I'm going to see if I can move that. So you don't need to add any quotes. You can write my first GUI commit message, and then you can hit commit. And then you can see that your source control graph down here at the bottom will have the commit messages that you have laid out. And we're still on the main branch within this directory. So the directories that I've been pulling up have all been on the main branch. So now we're going to create a branch on the command line. So we're going to go navigate back to this CLI directory. Maximize it. Hopefully it still make it a little bigger. And then go back to this directory here. So when we want to create a branch, we want to make sure we're branching off the desired branch. It can get kind of a little complicated quickly if we don't do that. So just as best practice, make sure you're always branching off the desired branch, which in this case is main. So just to double check, I know we're on main here because I can see it on the bottom left, but just in case, I'll run git checkout main, and that will switch you to your main branch. So because we're already there, we're already on main, so Git is smart and tells us that. So I'm going to create a new branch. So the way to do that, you can do that with git checkout and then the B flag. And then you can name your new branch anything you'd like, but in keeping with the examples previously, I'll run feature and then CLI. That's just an example. So when I hit enter, it's going to switch us to a new branch called feature CLI, and then you can see that populate down here on the bottom left. Okay, so I'm going to run that same example, but now on the other screen. Oops. What was that? Apologies. Not that. Turn off Copilot. Okay. So now to create a branch here. So now we are in the GUI directory. Thank you for everyone's patience earlier with that little kerfuffle. So to create a branch here, there are two options. You can do it both on the source control pane or via the command palette. So I'll show you both options here. So on the source control, you can check the ellipses here. If you navigate to source control, source control, click the ellipsis on here. You hover over branch. Sorry, it's a little small. I hope I don't know how to make options like that get bigger, but you hover over branch, and then you can click create branch. And then we're going to populate it. I'm going to populate it with the example. So we'll do feature CLI option 1, and then I'll hit enter. And then that will have the same process or the same output as what we did on the command line in the other directory. So option 2 would be to create a branch using the command palette. So if you do hit Control Shift P, or Command Shift P, depending on what operating system you're on, you can open up the command palette here. And if you type in git create branch, and this is going to branch off CLI1. So what I want to do here is create branch from, and then I want to do it from main. And then if I branch off from main, I'm going to label this feature CLI option 2, and then I'll be on option 2. So, and then you can just follow the prompts. And again, making sure that you're branching off the desired branch, which, you know, when you're in the thick of things can be kind of a process. So now let me shift back to the presentation here. Oh. Sorry about this. Let's take a look. All right, so all of what we covered was in the slides here. And we'll share this after the webinar. Okay. So now we're going to move on to collaborating in the cloud, which in this case means GitHub. So that means connecting to a remote repository to push and to pull code, like mentioned earlier. Okay. So to connect to a remote repository in GitHub means you want to push code. This does require some steps. You'll need to create the repository on GitHub, which we did previously. So I'll be using that as an example. And then you'll need to get the URL, either via the SSH protocol or via the HTTP protocol. Both do require the setup of an SSH key or a personal access token if you're going to use HTTP. Those processes won't be covered here just for the sake of time, but I did include some documentation to kind of get the SSH key set up. And if you need some support navigating that, there's a lot of documentation. So this part of the process will involve navigating both the command line and GitHub itself. So I'm going to navigate back to my screen here. Okay, so this is on the GUI. And that's still, there we go. All right, pardon again. Okay, so we've created the remote repository on GitHub. So now what we want to do is connect it, like I mentioned. Let's see if I can grab it again. Interesting. All right, so what we're going to do is basically connect this repository here to our Visual VS Code instance. So the way to do that, like I mentioned, the SSH key has already been set up, but to do that, the SSH key has already been set up. So you would click on code here. You can have options here as HTTPS, SSH, GitHub CLI. I chose SSH. We'll copy this URL to the clipboard here, and then I'll navigate back to Visual Studio Code. And this, when you hit, then we're going to do, let's see, this is going to be, oops, no. Okay. So we want to add a remote origin for this. So interesting. So I'm going to exit out of this, go up to the other directory, and I'm going to type in git remote add origin, and this will connect you to the GitHub repo that I just created. So that is not what I wanted to do. Pardon. Sorry. Okay, we're back. I'm going to grab here. All right, so like I mentioned, git remote add origin, and then you copy and paste the URL with SSH, and you hit enter. Maybe if I go back to example CLI, let's try that again. Up arrow. Okay. So when you hit enter, there's no error message, which is great. And then now, for instance, I want to push this feature branch. I want to push this feature branch into the Git repository the GitHub repository that we created earlier. So to do that, finally, you would do git push origin, and then feature /CLI, and hit enter. And you should get some output, a number of output from GitHub or from Git that just enumerate or that lists out some of the changes that were made. This presentation won't go into the details of what they mean, but usually when you see no error messages, that's a good sign. So to confirm, we'll navigate back to GitHub, and as you can see, this feature branch had some recent pushes about a couple seconds ago. Okay. So now we want to pull down code from an existing repository. So what I want to do now is navigate to a previously existing GitHub repo, just so you can see some of the differences in the code. And I had been playing around with my GitHub a little bit earlier. So a way to do this, I will go back to my repos. So I had existing here. And if I click into this, you'll want to grab. So same process. In order to connect to a remote repository, you'll hit code here. And then well, I chose SSH, so I'll copy that to the clipboard. And then I will want to go back to Visual Studio Code. And I want to clone. So we'll use git clone. Git clone. And then you want to type that in. And then you want to hit enter. And then you'll see that immediately on VS Code, the directory for the intro to Git that was already existing on GitHub will have the code, and we'll have the code base that you were pulling from on the remote. So let's take a look here. So I think that there are a number of ways to keep it organized, and GitHub does a great job. So appreciate the GitHub teams. So now maybe this might be a good time to pause for any questions. I appreciate everyone kind of following around with the moving back and forth live on the terminal and on VS Code. So I'll stop for any questions now.
So yes, there have been some questions, and we've also had people in the audience answer questions. So that's that. So I can read some of the. Somebody asked if there's a way to see the global configurations for a user setting.
There should be. The command to see that does escape me. I can provide it after the presentation.
So Randall in the chat wrote, it's git space config space / list.
Perfect.
You can try that one. Okay.
Yeah, you can see a bunch of different configurations. So yeah, you can see I might have to change some of these after the presentation.
Okay. And Randall also has a suggestion. The VS, which I didn't know about, the VS Code Git Graph extension is quite helpful for visualizing and acting on branches.
Oh, perfect. I didn't know that. Maybe I'll add that right now.
Okay. Git Graph.
Git Graph. Okay, so in order to add extensions, you can go onto the side panel, and it'll look like little boxes here. Navigate in Git Graph like this.
There's a space between Git and Graph.
Okay, perfect. All right. Oh, so 9 million downloads. Take a quick look here, and then install. Oh, I've never used this before. That's awesome. Okay. Yeah, so I'll take a look at Git Graph. Randall, thanks for mentioning. I'm sorry if I'm mispronouncing the name. Thank you so much for sharing that. Appreciate it.
Well, somebody else also asked about what is the idea of a branch? What?
Sure. So a branch is almost like it would be like a fork. So for instance, if you have work on one, it's almost like branches of a tree. I guess that would be the way to describe it. So a branch is like a separate version of work that always goes back to a root, or always goes back to a main trunk. And there are multiple there's a lot of ways to branch off in Git, and I'm always happy to answer more later though if you'd like. What about branching? Is it the type of work? Is it the process of branching? More context would be helpful.
So another question is, are main and master branch the same?
So you can name a branch anything you'd like. Git by default has tended to, when you initialize a Git repository, Git will automatically name your branch main. It used to be that it renamed it master, but in 2020 that changed. So you can create by any means that you can create a master branch, and like anything you want, you can call it anything you like. But for the purposes of keeping development straight, it's usually convention to have it named main or master.
Okay, and then the next question is, I missed the difference between git remote add origin and git clone. So what are the differences between those two commands?
Sure. So git remote add origin connects you to a local repository. So it's almost like you are reaching for that local repository. And then git clone is basically a way for you to pull down the code that already exists. So for instance, if you're working on a more mature code base, you can pull down all the features and all the code, not necessarily some of the branches that exist, but git clone is almost like a wrapper around a lot of other commands. Let me see. It can wrap around other commands. Like it creates a new directory. It creates a new directory, and let me see. And it checks out the latest it does a lot of things simultaneously in order to get the code that you need. Let me see. Yeah, so it wraps around other commands, that creates a new directory, kind of goes into that new directory, runs the git init command, adds the remote for you so you don't have to do it yourself, runs a git fetch, and then checks out the latest commit. It's quite useful.
Josanne asks, please could you show the line code again for pushing the branch?
Sure. Sure. So we'll go back here to kind of navigate that out a little quickly. So I'm going to make some changes to this file here. Sample pushing branch. Hit save. So this is kind of a good example of workflow. So I want to push up my commits. Okay. Okay. All right. So I missed the name. Apologies. But now I'm gonna run this push commit. So you'd be git push origin, and then the name of your branch. So I'm on feature /CLI. I'm going to push to that branch, feature CLI. And then if you hit enter, you will see that your changes have been pushed up. I hope that answers. Oh, sorry.
Sam, it does. So I have a question for you as well. Can you also type git remote -v so people can see the two remotes?
Oh, sure.
So is there one remote? Is that what's happening? And you're pushing to one branch?
Correct. Yes.
Got it. Okay. So I had asked Randall, where can we visualize the Git Graph graph? And Randall says that when you click on Git Graph button in the bottom row, the graph will appear in a tab window.
Oh, cool.
Oh, so maybe check that out.
Okay. Okay. So show branches. You can see all the branches here. Show remote branches. Oh, that's really neat. Thanks, Randall.
So the next question is, what's the difference between git pull and git fetch? Which one is preferred and why?
That's a good question. I think it's a matter of preference, but I would say that git pull is more standard across the board. Git pull is a combination of two commands called git fetch and git merge. So git pull will, like git fetch will grab the changes from wherever from the remote, but it won't merge them into your local branch. Whereas git pull will combine those two, so you don't have to think about doing separate commands. I hope that answers.
Okay, yes. And the next question is, if git stash keeps a saved copy of the working directory, then why is it different from normal staging and committing?
Oh, that is a great question. I don't have a specific answer for you, but I think that there is a there should be an answer to that. So I will get back to you. Thank you. So, or someone in the audience knows that'd be wonderful.
Okay. Yeah, we'll keep that there. See if somebody else knows. I'll put it in the chat again.
Okay.
The next question is, what's the difference between using HTTPS and the SSH keys?
I think they're different protocols, different security protocols. So HTTP stands for Hypertext Transfer Protocol, and SSH stands for Secure Shell Protocol. There are different keys. So SSH needs something called an SSH key, and there are a certain number of commands, or you can generate it. You can generate it with an SSH gen command. And HTTP, you need something called a personal access token. That's something new that GitHub rolled out. I forget when, but it was recently. It used to be that you could authenticate your account with only a password, but for security purposes, they moved to a personal access token method. They are two protocols basically for connecting to your GitHub repository.
Right. And just to add, in the old days, you wouldn't, you could do the HTTP clone and enter in your password every time, but now it's different. Whereas once you set your SSH keys, you don't have to enter in your password every time you make a connection to GitHub, right?
Yeah,
Right.
the SSH method has streamlined a lot of things, I think.
Okay. And that's all the questions so far.
Okay, amazing. Thanks, everyone. Really great to learn about Git Graph too. It's been good. Okay, so I'll move on now to just troubleshooting. Pardon. Yeah, so all these commands will be available on the presentation here. We'll share that after the webinar. Okay, Git clone. So we'll go over troubleshooting some common Git issues. So some common Git issues that you might see that you might run into development. There's a number of them. So they include like detached heads, or a commit rather than a branch is checked out. That can cause some issues. Reconciling some divergent branches that might come out, and some merge conflicts. Merge conflicts are very common, so I'll discuss them here. They arise. Let me move on to the next slide. So merge conflicts arise when developers are changing the same part of the same file differently in the two branches that are merging. Usually these conflicts need to be resolved manually on your code editor and can require some level of coordination depending on the changes that are needed. GitHub can handle your code changes and your merges, but for the purposes of the demo, I can simulate a merge conflict here with two different branches via the command line. So before that, just to go over kind of the high-level overview of how to solve merge conflicts. So we need to reopen your file, resolve the conflicts manually, meaning going over your edits and then committing the results. And then one way to kind of prevent this, they're challenging to prevent, but they happen during the course of development. So staying vigilant, committing early and often on your branches, and having shorter pull requests can help reduce some of these instances. So I'm going to simulate a merge conflict now on VS Code. Let's resume screen. And then can you all see my VS Code again?
Not yet.
Not yet? Okay. Let's try. How about now?
Yes.
Okay. Okay. So I'm going to simulate a merge conflict now. So I'm on this feature CLI. To simplify it, I'm going to go back to main. So to do that, you do git checkout main here. And then I'm going to edit this example file here. This was on. So editing the file, git, and then there's a shortcut that you could do. You could just do git add dot, and then that's going to add all the files. But that can also, depending on how much you're working on, that can cause some issues. So I like to just grab the file name and commit specifically. Okay, so I've committed my file. I haven't pushed it up yet. So now I just want to demonstrate it here locally. So now I'm going to go on to a different branch and make a same change on this same line, but make something else. So maybe a little unclear, apologies. Okay. And I was able to check out a different branch because I had already committed.
Sam?
Yes?
So before you do the git commit, can you do git status again so people can see the red change to green?
Oh, yeah, sure. Thanks, Reshma. Okay, so yeah, so we git add and run a git status, and you can see that, so this is a kind of live example too. So you can see that this intro to Git, when I ran, as soon as I ran the add command, it changed to green. And this is also telling us that I haven't introduced that directory from GitHub that I pulled in. So it's untracked, but I pulled it in locally. So Git's telling me like, oh, do you want to track this intro to Git _ existing folder? Do you want to track that locally here in your Git repo? But for the purposes of this example, I just want to track this CLI text file. So I've added it, and then you can do git status and then git commit. And then, okay. And then if you ever get confused, or if you just want to see what the commands you've run, because it can get a little confusing, you can run a command called history. And then that'll show you a list of all the commands that you've run in the past, or not all of them, but all the ones that you've run in this terminal session, and then you can return. So, and then Control K can clear out your the visuals here. So in order to run a merge conflict, so the merge conflicts can be a little interesting. There's some terminology called accept current change and accept incoming change. So let me do that now real quick. Just I want to check out main. All right. So I'm going to do a git merge. And then that's going to merge the feature branch or whichever branch into the main branch that I'm checked out on. And then if I hit enter, there should be a merge conflict that arises.
Yeah.
Mm-hmm.
Okay, I was just curious. I wonder, like, next time if you do git checkout main, I've never seen Git Graph before. I wonder what it shows us. Do you know what I mean?
Oh, sure. Yeah. 1 second. Hold on. If I do Git Graph here, yeah. So this is interesting. I'll go back to main. Oh, interesting. So we need to resolve your current index. All right, let me go back to Git Graph.
I think it's at the bottom. So.
Oh, at the bottom. Thank you. Okay. So I introduced a merge conflict example, or I introduced an item on main here, and then I introduced the same element here, or I introduced a different element here on feature CLI. Interesting. I've never actually, Randall, do you have are you able to edit? Oh, interesting. It's almost like having these arrows here. So if I do previous conflict, next conflict, run code, open file, previous change, next change. Okay. Testing things out. So this is yeah, maybe this Git graph can kind of supplant the example that I was going to go for. If I try run code, oh, there's nothing to run. It's just a text file. Previous conflict, no merge conflicts in this file. What about this one? Previous change, next change. Rishma, do you have any thoughts?
I don't. I just wonder, like, if you do these steps, if we can see whatever is changing in Git Graph, like what it does.
Yeah, okay.
Yeah.
Maybe if I have, so I have Git Graph here.
Okay.
And if I go, oh, interesting. Description. Let's see. Let me try Git status again. I don't think Git status should do anything, but maybe it will. Nope. Okay. So I'm going to try the same merge conflict again. So I'm on main, and I'm going to revert, or I'm going to try the same git merge command, enter. Merging is not possible because you have unmerged files. Fix them up in the work tree and then use git add rm file as appropriate to macro resolution and make a commit. So maybe if I had Git Graph open before I ran that command, I would have seen something here with a merge conflict, but I don't see it.
Okay. Yeah, we can move on. I just thought that it would show some changes as you were making it.
Yeah. Maybe we can try it. Maybe I'll keep it open. So I'll go back here. And then, yeah, so again, this is simulating a merge conflict where I was editing the same file in 2 different branches. So the terminology, I always have to refer back to it. But in order to resolve, you do need to go into each file, and Git will automatically add these angle brackets that you have to remove manually, as well as these equal sign symbols that you also have to remove manually. So let's see, maybe I can do, so I'm going to split the pane left, maybe split it right. And then maybe you can see if something changes on Git Graph, and I'll change out this pane here. Okay. Hopefully that's okay. Okay, so we are on the main branch. The intention is to kind of resolve these conflicts so I can get the correct or the desired changes merged into main. So accept current change here indicates that the changes that are on that you want to keep the changes that are on the branch that you're on. So we want to keep, do we want to keep ABC123 simulating merge conflict on main, or do we want to add this in? So because I want to add my changes from the other branch, I'm going to click something called accept incoming change. It means that you want to incorporate the changes that are coming in, that you're merging in from the other branch. In this case, feature CLI. So if I hit accept incoming change, this line will be merged into main. Accept. And then we will click resolve for merge editor. Oh, I don't. That's another option as well. So we have, let me see, complete merge. Interesting. Live troubleshooting. I usually do it manually on my file, but there are multiple ways of resolving merge conflicts. Feature, yeah. So we wanted to get in this, and then yeah, because of what I had selected, the result will come down in this here. So 1 conflict remaining. So let's go back here. Go to next conflict. Why doesn't it? Interesting. So if I hit that little arrow, VS Code is telling me that the changes that I had made to simulate the merge conflict extra here won't be made. So let's do it back again. Accept incoming. There we go. Yeah, so incoming is feature CLI. And then we want to save. I'm going to exit out of that. And then I'm on main. And then we'll go back to the command line. Just run a git status again to see what's up. I will want to add my example file. And then if you can do tab complete just to save yourself a little bit of time, hit enter. Message, solving, merge conflict. And then, so now I'm going to, we should see this show up on our, on the GitHub, on the main branch on GitHub. So I'm going to do git push origin main, hit enter. Oh, interesting. The remote work. So this is a way to, if you do git pull, we'd have to go through that process again. So I guess this is a live example of merge conflicts sometimes causing some issues. So do git status again. So I'm on main. Git add. I want to do intro to git pull main. I don't think this will do anything, but let me try. Divergent branches. So this is going to get us over into our next feature called Git rebase. So in the course of development, you'll see kind of error messages like this that are a little frustrating, but you want to kind of move forward in the course of development. And one way to do that is through Git rebase. So Git, thankfully, when you run into problems, can help you troubleshoot with the automatic input that it gives you. So Git rebase is a command that's similar to Git merge, and it's used to move all of the commits from a feature branch back onto the desired branch that you're on. So I'm going to follow the steps that that Git is telling me to follow, and the end goal is to see the changes being reflected on GitHub. So I will tried this before in the past, but I need to double check. So I'll do git config. And this a rebasing, it's really important to talk about, in my opinion, rebasing or these kinds of processes with your teammates, because Git rebase can be pretty destructive. It can clean up your commit history, but it can also be a little destructive to if folks are using different versions of main. So the recommendation is to talk to some folks. Let's try this. So you can hint by do so here. If I rebase true, I'll run a git status again. Okay. If I do this, so this, I'll use the git add dot, and then once I do that, the untracked files will be tracked. Whoa, you've added a git repository inside your git repository. Clones of the outer repo will not contain the contents of the embedded repo and will not know how to obtain it. If you added this path by mistake, let's see, let's try again. Git status. So what I've done is when I ran my git clone, I ran it within an existing repository, and that created some kind of conflicts and some kind of just error messages that we're seeing here on the command line. But these are maybe, warning, adding embedded Git repository. So it's not explicitly telling me that I cannot do what I wanted to do, which is to commit to this intro to Git existing repository that I pulled down from GitHub. So at this point, we could either, because this is an example, we can either just kind of go down the rabbit hole in the tree just to see what happens. And then, but in the course of professional development, this is probably, it would be best to pause and troubleshoot. But for the purposes of learning, we'll take a close look here. Commit pulling from remote. Okay. So the purpose was to resolve merge conflicts. Git pull. So no tracking information for the current branch on main. That makes sense. Please specify which branch you want to rebase again. So we want to rebase off main from the remote. If you just said tracking, let's try this. Here. Main. Great. So now this main branch is set up to track origin main from the GitHub remote repository. So if I run a git status just to see where I am. Okay, so this is good. It indicates just kind of the status of how your branches and your commits are going. So this main branch, our local main branch and origin main from the remote have diverged and have 6 and 1 different commits each respectively. Use git pull if you want to integrate the remote branch with yours. So I do want to kind of navigate through this git process. So I'm going to run git pull. Ah, perfect. So we have the git. So this kind of might simulate something you might see on development, which is like your local is not aligned with the main branch, or your local main is not aligned with main remotely. So now what we want to do is resolve all commands manually, mark them as resolved, and then run git rebase continue. I don't know about that. So I want to keep this. I want to keep this change because that was the whole intention from the beginning. So I'm going to hit accept current change. I'm going to save it with Control S. I'll run a git status again. I'll copy my file. I'll run git add to track that file, the changes that are being made. Hit enter. Okay. So we'll see now that a lot of the error messages have gone away. Error messages are going away, and in my opinion, is not necessarily exactly what we want. We want to resolve the problems. So we want to get status again to get the green. We want to git commit solving merge conflicts round 2. And now we're rebasing. We are this is the with rebasing. We're moving all the features, all the commits made in one branch onto the next branch, and we're probably going to erase some commit history this way. So I'm going to do git push. Oh my goodness. Updates were rejected because a pushed branch tip is behind its remote counterpart. If you want to integrate the remote changes, use git pull. Yeah, so I think that this is an interesting, like, troubleshooting in Git can be a little bit complicated. So I can continue down the demo, but I also want to be mindful of time. But from the purposes of resolving, I do want to try to resolve. So let's try this. Git rebase continue. Yeah, so Git is great. I am stopping in case you still have something valuable there, because we are in learning mode. We have some examples, but it would be best to, in the course of development, to pause. Let's see. Continue merge elements. Add. I forgot this rebase continue. Let's do it again. Okay. And then we'll grab the commit here as Git had mentioned. So we're marking them as we ran our Git add. I should have run a Git status, but we'll run that again just for completion's sake. Sorry. Okay. Status. Making a rebase command. All conflicts, you are currently rebasing branch main on here. All conflicts are fixed, so now Git's telling us to run git rebase continue. So I'm going to do that. Okay. So we successfully rebased and updated the references in the head. So that just that shifted all the commits from my local main on onto what was already on main and remote. So if I do git status again, all right, great. We're back on branch main. Our branch is ahead of origin main, which there's remote by 4 commits. I'm going to push main. And then we have pushed all our code. Okay, so thank you for bearing with live troubleshooting. I think that Git can be a little bit challenging. And then last, let me see. And then if we can go up here into our Git repository. Let's see, why doesn't it want to go? Maybe it's here. Live. Yeah, updated now. We'll see that this branch had some commits a minute ago. And then this is the other repository. Oh, it's so fascinating. This is the repository that we had pulled from in my other one. And then that was GitHub is reflecting the changes that we had made. Okay. And then last but not least, I'll go back to the git ignore file. So a git ignore file is important. So you can keep files that you don't want committed. So you can keep them out of a shared repository. So git ignore, GitHub has a lot of templates. I chose a Python template, but you can, when you create repositories on GitHub, you can see which, just what language or what framework you'd like to use. And some files, for instance, to add for exclusion in the git ignore include log files, because that like some folks can kind of take that, and that can be a security risk. Or if you want to exclude files that are produced by the build system, that's important too. So in the course of web development, for instance, like you would want to exclude, your environment files, so your .env files. You'd also want to exclude, and if you're using JavaScript or Node, you'd want to exclude all your Node modules. Those take up tremendous space and are usually good to exclude. So if we click here, these are all the files that GitHub has chosen to exclude with Python builds. So PyCache, other extensions. I'm not necessarily familiar with all of them, but it's nice that they're here. So go down. Yeah. So if you're using Django or Flask, and you can obviously commit. And a git ignore file is preceded by a dot, meaning that it's a hidden file on your system. And then lastly, we have some continued learning. A couple things. So Git stash was mentioned earlier. Git stash is a way of saving your changes. And of course, sometimes if you're moving quickly, you need to use Git stash so you can go back to your changes. It won't get rid of them for you, but it'll allow you to move forward. There's also something called Git ref logs. Ref log stands for reference logs. So you can take a look at the logs that are just the logs of your development. And that Git Graph development is, Git Graph extension is great too, to allow you to visualize. There's so many awesome tools out there. Git cherry pick is also is an option. It's more advanced. You would need to you'd basically attach a commit to you're cherry picking. You're grabbing a commit from one branch and attaching it to another. That takes a little bit of care. And you'll notice there's something called aliases to allow your Git development to move a little bit faster. For the purposes of clarity, we were going through Git status and different commands to get a sense of the flow. And then there's so much more, but I chose something called Git tags. If you're going to release features, it allows you to go back and track track your releases. So there's so many questions, but I did want to leave time for Q&A now, if there's still any.
So we had some questions on Git stash. If you're able to answer those. Yeah. So the question was, I guess, do you have time to do a quick example with Git stash?
Sure.
Okay.
Yeah, let's pull it up. All right, so we'll go back. Thanks everyone for bearing with the long back and forth with all of this. Okay, so if we do Git stash, let's go back here. Git stash. So let's do an example. So I'll create a new branch because I think that it might simulate development, like you're working on checkout B, feature TBD. Okay, so that's off main. Okay, so I'm gonna, make a Python file.
And Randall says that the Git stash feature shows up nicely in Git Graph. So.
Oh, perfect, awesome. Why doesn't it? Why can't I show? Oh, there we go. Git Graph. Okay. I'll do new file py. So it's py.py stands for a Python extension. So we'll create a, let's see, time to cool thing. I'm creating a Python creating a hello world Python Python function. Hello data umbrella. Okay, well, I'm working on my new cool thing. I need to add, a lot of different things, but you know what? In the course of development, I don't have time to go back. So I don't have time to save. I don't have time to go through my, let's do this, right? Yeah, I definitely don't have time to go through the whole process of what we all did. And I know that I can always come back to this feature TBD branch. Oh, there's so much. Let me just do this, TBD here. And you want to stash it. So what you do is you'll come back to this branch later. So all you can do here is run git stash. And you hit enter. Wait, I want to make sure that it shows up on Git Graph. Sorry, Randall, if this is not working out great. So I'm going to hit enter. No local changes to save. Git stash. That's so funny. I'm gonna do git status again. Git add. I'll do dot status. All right. So I have committed. I think a git stash is good for when you have local commits that you don't necessarily want to push up to a shared repository. And then different teams have different methods of development, but that's just an option for you if you'd like. So I don't want to push up these changes. They're not ready for whatever prime time means nowadays. So we'll do git stash. Oh, why doesn't that work? I don't think I've used git stash that often. I've used it in other places, but so git stash can be used if you want to. The Git documentation is stash the changes in a dirty working directory away. So we'll do git stash branch feature TBD. No stash entries found. Why doesn't it work? Maybe it's git stash create. And I'm looking at some Git documentation. We'll link the documentation at the end of the presentation. But git stash create new. No local changes to save.
The only thing I can think of is the git stash works before the commit.
Oh, okay.
When it's still red, which means it might even be before the add, but I don't know.
Okay. Okay, before the commit. So we have, I'm saving it. If I do, oh, if you want to git add, okay. Git status, all right. New file. Okay, so I've added the file. I have run. Okay, let's try this. So we've added the file. We don't have commits. I'll run git stash now. Enter. Great. Oh, thank you, Reshma. All right, so git stash, the git stash command that I just ran. So git has some output here. So it saved this working directory and index state work in progress on the feature. This is the last few characters of the checksum that was mentioned a little bit earlier, and that can be used to track your changes. And then the git stash shows up here.
Can you also type? Somebody had put in this in the chat. Can you also type git stash space show?
Git stash show. All right, and then that should show.
Okay. All right, and then somebody else said that if you want to show, if you want to is it unstash? If you do git stash pop, does it unstash it?
Let's try.
Okay, git stash pop.
Git stash pop. There's a few options like index, Q. Let me try. I'm just try it here. Yeah.
And then if you do git status, does it show up in red again?
Git status. It seems, yeah.
Oh, okay, cool.
Perfect. Okay, so yes, okay, so we do. So what Reshma had mentioned and other folks had mentioned is just a way of moving, like just moving your changes in a way where you can just keep them in your directories, in your Git repositories. So let's try that one more time. So I had made an incorrect doc string here with only one quote. It was originally called TBD. And then if I wanted to save my changes here with this new doc string. Git add here. Okay. But I don't want to commit anything. So maybe git stash is a way of saving changes before even the commit part of the process. Because commits can kind of can maybe dirty up your directory. So we'll do git stash again. And then git stash. So it changed my doc string here from the correct version to this incorrect version, which is what I had previously. So it saved the working directory and index state on feature. And then it seems like because we had popped the stash, so popping is a term that is a term that indicates removing from the end of a list or a data structure like that. It seems like it just captures the same if it just captures the same process. And then if you run git stash list, let's see. So git stash list We'll show you a new test file. What about git stash show? Yeah. So, and then you can customize your environment to be a little more color coded. But this git stash list can show you. Maybe you can run another command and see. Fix doc strings. Okay. All right, so I made another change on this file, and I also want to stash this. So I'm going to run another git stash command. And then that, oh, this Git Graph is great. It shows you how many, just how many times you've actually stashed something, and it seems like that non-additive commands aren't reflected here on git stash. So we'll do git stash list again, and then you should see, maybe you should see like another line here, so 2 lines. Git stash list, great, and it shows up. It shows the different. I guess it shows the existence of a stash, but not necessarily the changes that were made, which makes sense. Thanks, Randall, and everyone for working on that. Are there any other questions at all?
Hey, Sam. So no more questions. We had so many. Thank you so much for being flexible and trying different things. And it was really, really helpful. Definitely, personally for me, because I've gotten stuck on that git stash a number of times. I can stash it, but then I never know how to get it back. So this has been really helpful. But yeah, thank you so much. I know live coding is not easy at all. So so we had a lot of questions that have been answered throughout, and this is being recorded. We'll probably get the recording by tonight, so have it up within the next 24 hours. Randall says, disclaimer, I learned about Git having lunch with Linus in Portland the second month he was working on it. Oh, wow. Made the first Google Tech Talk on Git as well. Wow, amazing. That's very impressive. Oh, thanks so much. And Git Graph, never heard of Git Graph, but apparently it has 9 million downloads in the VSC, plugin area. So it's legit. Okay, and with that, we are ending the webinar. The video will be posted, and a link to the slides will be posted as well. Thank you, everybody, for joining. Thank you, everybody, for all your questions and all your answers, and everybody. Okay.